What's up, everyone? Am I audible? What's up, audible? Sorry, what's up? What's up, guys? Am I audible? क्या हम ऑडिबल हैं? क्या आप हमें सुन सकते हैं? क्या आप हमें सुन सकते हैं? आ गए हम आ गए। थोड़ा फ्रेश हो लिए। Look fresh, isn't it? Do you think I have worked for 9-10 hours in the day? Ha ha ha! I look fresh, isn't it? Hi everyone, what's up? Okay, Malan, bye bye. Everyone join in, then we'll get started. Let's quickly wrap up the introduction part till everyone just joins in. Okay, let's just quickly wrap up the part. So for everyone who's new out here, I'll tell you my introduction. I'm known as Raj Vikramaditya in the programming community. I'm currently a software engineer. I have been into competitive programming from the past, I think, 5 years, and I've been teaching from the last couple of years. I also run a YouTube channel which goes by the name Take You Forward, which has around 1 lakh plus subscribers. The subjects that I majorly expertise in teaching are competitive programming, data structure algorithms, C++, and everything that's related to interview preparation. So if you're willing to take anything at Unacademy platform, just make sure you use the coupon code Striver in order to get the 10% exclusive discount. By the way, batches नया जल्दी आने वाला है. Subscription probably model has been stopped, but you will definitely find a new model very soon. Okay, so without actually wasting any time, let's get to the promotion part, which is a mandatory part I have to do. So yeah, Relevel, now it's absolutely free for you people. So Relevel is basically India's first hiring platform. So a lot of time what happens is you want to apply to companies, but you don't find referrals, you don't find a lot of companies visiting your campus, or a lot of times you don't have the necessary degree, or probably you are lacking at a CGPA, and there might be a lot of issues. So if you are very good at coding, development, if you have talent, in short, then you can definitely apply to any companies that is listed at Relevel. Okay, now what is the benefits of Relevel? You will get across like 50 to 60 plus companies, which includes India's top startups, unicorns like Cred, Razorpay, then there's Urban Ladder, and there's a lot of Yellow Messenger, 1MG, Codenation. There's a lot of other companies which does pay around 15 LPA, 20 LPA, 25 LPA, 1000 plus openings are there. So what you just need to do is you need to register and you need to give the test, and once you can give the test, you'll get a score by which you can apply across Relevel. Now everything is very swift enough. If you give a test within 15 days, you might get hired if your interviews go very well. So there are three kinds of jobs that is available over here: business development, front end development, back end development. Okay, so what you need to do is you just need to book a slot when you want to give the Relevel test. So the slots are limited, so I'll suggest you to book as fast as possible. And once you give the test, just make sure you create the video resume, and after that video resume will be forwarded to all the companies. And yeah, what are you waiting for? Go and register for Relevel. The links are in the description. So also if you haven't checked out the Telegram group of this particular channel, make sure you check it out. The link is again in the description. And if you're new to the channel, before starting, I'll highly recommend, please do consider giving this a like. Okay, that's the first thing you should give. And if you're new to the channel, do consider subscribing. You can press on the bell icon. The generic time that I do come online is 10 o'clock. Not every day, but yeah, you can come and check on the channel at 10 o'clock. If I'm online, you can study from me. So yeah, without wasting any time, let's tell you about today's agenda. ठीक है, आज का एजेंडा बता देते हैं आपको. So what's today's agenda? I'll start off with DSU, that's disjoint set union. Okay, then I will basically do the path compression technique. Then I'll teach you the union by rank. Then I'll teach you the union by size. Okay, right after that I will do couple of questions. Both of them were asked in Google in the past year. both of them Google questions based on DSU. Like I'll do 2 questions on DSU, and I think apart from that I will do 1 question probably if time permits me. अरे यार ये चल क्यों नहीं रहा, पेंसिल को मैं क्या कर रहा हूँ, पगला गया हूँ, एक सेकेंड, मैं पेंसिल इज नॉट वर्किंग, अब क्या हो गया भाई, वेट, I'm not sure what happened to my pencil, but yeah, कुछ तो हुआ है, pencil just stopped working. देखता हूँ, रुको एक सेकेंड. या चल रहा है, अब चल रहा है. क्या वो है, 10,000 का पेंसिल आता है भाई, कहाँ से बदले, बहुत महंगा है, 10,000 का छोटू सा पेंसिल है, इतनी औकात नहीं है बदलने की. So 1 question from Code Forces. Okay, that's what I'm gonna do you for today. So that's what I'm planning to do for today. ठीक है, इंक भर दो. Okay, that's what I'm going to do for today. So yeah, how many of you know about disjoint set union? How many of you know about disjoint set union? कितने लोगों को पता है disjoint set union? Me, okay, Tech JD knows about it. मुझे आता है, ठीक है, कोई बात नहीं, बहुत लोगों को आता है, कोई बात नहीं, no clue, okay. Don't know, okay. So I'm assuming most of you do not know it. Yes, I'm assuming again most of you do not know it, and I'll be teaching according to that. What I can assure you is today when you end the class, you will have no problems in disjoint set union. You can solve Google level of questions ऐसे मतलब मजाक में बना लोगे, मैं बता रहा हूँ, बस ध्यान दो लास्ट तक, मजा आ जाएगा. ठीक है, शुरू करते हैं. कोई नहीं, जो टॉपिक्स टफ लगता है आके इधर पढ़ लिया करो, यू विल फाइंड इट इजी. सो लेट्स फर्स्ट अंडरस्टैंड व्हाट्स द यूज केस ऑफ दिस. टू फिगर आउट इफ 2 nodes belong to same component or not. Do you remember what's the definition of component from the first class? You need to figure out if 2 nodes belong to the same component or not. Okay, that's generally the use case. इसीलिए तो मैं अभी नया लिस्ट तो नहीं, बट बेसिकली द सीपी लिस्ट का कुछ तो इशू था, तो इसीलिए मैंने स्नैक डाउन का एक वीडियो बनाया स्ट्राइवर चैनल पे, उस पर रिसोर्सेज बताए, यू कैन फॉलो दैट नाउ. ठीक है संदीप. ओके, लेट्स अंडरस्टैंड व्हाट डज दिस मीन. So there are basically 2 operations in disjoint set union. One is the union operation, remember this, and the next one is the find parent operation. Okay, union operation and find parent operation. So you're going to basically learn about both the operations. So assume I'm giving you 7 nodes. Okay, and initially disjoint set union, when you start off, you say that all the nodes are single. Yes, whenever you start off, you say that all the nodes are single. So what I'll say is there is 7 nodes and all of them are single. Okay, so there are 7 nodes and you will say that all of them are single. So I will give you some queries. So the first query that I give you, I'm saying, hey, why don't you do a union of 1 and 2? So guys, just remember everyone, you can assume everyone to be a like graph kind of a data structure or a tree kind of a data structure. Okay, so everyone is the root of, like for 1 I can say 1 is the root, for 2 is the root, 3 is the root, 4 is the root, 5 is the root, 6 is the root, 7 is the root. You can call this as the root of the tree or as the ultimate parent. Like you can call it as any of this, either the root of the tree or you can call it as the ultimate parent. Okay, now if someone says, hey, why don't you do an union of 1 2, so what you will do is you will say, hey, who is 1's ultimate parent or root. So you'll find the ultimate parent of or the root of the 1 to be 1. Similarly, you'll say who's the ultimate parent of 2, and you'll find that the ultimate parent of 2 is 2. So what you will do is you will combine them. Okay, so let's understand how does this work logically. You'll take this 2 and you'll connect it to over here. Okay, now it could have been the other way around, where you say that okay, let's take that 1 and connect to 2, or it can be this way also, where you say hey, let's take the 2 and connect it to 1. It can be either ways, it doesn't matter, as long like we will come up to that how to decide on which portion. But as of now, let's imagine it doesn't matter you connect whom to whom, as long as you connect 1 and 2, it's absolutely okay. So I can say first union function is done, so I'm done. Okay, next assume someone comes up and says hey, can you do me a union of 2 and 3. Hey, can you do me a union of 2 and 3? So generally what will happen is you will say hey, who is 2's root or ultimate parent. You will ask who is 2's root or ultimate parent. So can you tell me who is 2's root or ultimate parent? बता सकते हो कौन है 2 का अल्टीमेट रूट? So 2's ultimate parent is nothing but 1, and 3's ultimate parent is 1, right? So what you will do is 3's ultimate is 3. So what you will do is you will basically connect 1 and 3. You'll basically connect 1 and 3. So this is how the connection will look like. Remember this. The connection will always happen between the roots of both the guys. The connection will always happen between the roots of both the guys. That's very essential in disjoint set union. Why? Because it's a data structure. They have designed it in such a way. We'll come to that why. Don't worry about that. You will understand as I move forward. So this is what I've done. So the second union operation is also done. Okay. Let's do the next union operation. So someone comes up and says, can you union 4 and 5? So let's do union for 4 and 5. So 4 and 5 will be something like this. Okay. Now someone comes up and says union of 6 and 7. So it will be something like this. So union of 4 and 5 is done. Union of 6 and 7 is done. Now if someone comes up and says union of, can you do me a union of 5 and 7? So can you tell me which root will get connected to which root? If I say union of 5 and 7, can you tell me that? If I say union of 5 and 7, which root will get connected to which root? बता पाओगे? Can you tell me that? Which root will get connected to which root? Yeah, 4 to 6. Yeah, 6 to 4 or 4 to 6. It can be vice versa. It can be 4 to 6 or it can be 6 to 4. It can be either ways. Okay. So what I'll do is, for doing this, probably I can take it like this. 6 and 7. Yes, for doing this, I can take it like this. 6 and 7. Okay. Now someone comes up and says me, so this will go over there. So this will something like this. Okay. Now someone comes up and says me, hey, can you do me a union of 2 and 7? So can you tell me now which one will you add to which? Can you tell me which one will you add to which? Yes, 1 and 4. Yeah, perfect. 1 and 4. No, 1 and 4. For this guy, it's 1. For this guy, it's 4. Remember, it's always about the ultimate parent or the root. The ultimate parent or the root. So if I connect this, probably I can have something like 1. Like it can be either ways, but yeah, let's connect it like this. It can be either ways, but I decided to connect it like this. So can I say, after I have done all the union operations, this will look something like this. Now if someone comes up and says, hey, can you tell me if 2 and 7 belong to the same component? Can you tell me how will you determine if they belong to the same component? Can you tell me if 2 and 7 belong to the same component? How will you determine? Very simple. You will say, hey 2, who is your ultimate parent? Hey 2, who is the ultimate parent? So you will say the ultimate parent of 2 is 4. Hey 7, who is your ultimate parent? 7 will say, hey, my ultimate parent is 4. So what we see is both of theirs ultimate parent or the root eventually comes out to be same. So in whenever they are asking you if they belong to the same component or not, what you can do is you can check their ultimate parents. Yes, what you can do is you can check their ultimate parents, if the ultimate parents of both the 2s and 7s come out to be same, you can say that they belong to the same component, or you can be like, hey, they do not belong to the same component. Make sense? Make sense to everyone? Has everyone understood the data structure? Now I'll come to optimizations. Over here, the ultimate parent will be 4. Remember, this is the ultimate parent now. For 1, this is the ultimate parent. For 2, this is the ultimate parent. For 5, this is the ultimate parent. For 3, the ultimate parent is this. For 6, the ultimate parent is this. For 7, the ultimate parent is this. Whenever I say ultimate parent, it means the root of the tree. Okay? Not in same component. Okay, someone did ask me not in same component का example दो. चलो दे देते हैं. Let's eliminate the last union operation that we did. Let's eliminate the last union operation that we did. Okay, so if we eliminate the last union operation, can I say we will have something like this, right? Like just before the last union operation. So in this case, if someone says does 2 and 7 belong to the same component, right before the last union operation, what will you say? Hey 2, who is the ultimate parent? It will be 1. Hey 7, who is the ultimate parent? That will come out to be 4. So what I figure out is the ultimate parents of both the 2s and 7s are actually different, and if they are different, I can say, hey, the 2 lies in this component, whereas the 7 lies in this component. Got it? To check for 2 nodes in the same, yeah, you could have simply done BFS, but yeah, we'll come to optimizations and learning a data structure which is very fast. Okay. But when we are taking union of 2 and 7, we are connecting to 1. How is the ultimate parent 4 and not 1? Because you're taking this and you're connecting it like this. We are doing the other way. We are taking this guy and we are connecting it here. We are doing it the other way. Like we are not taking this and connecting it like this. We are doing the other way. I just wanted to show you the other way. Okay. Doing the other way, whereas saying 1 will get connected to 4 and 4 will not get connected to. Is that the other way? Okay. Now coming to one very quick question. Did you understand why did I connect everything to the ultimate parent? Now there's a very interesting reason for that. Now imagine if I would have not connected to the ultimate parent. Just imagine if something like this will come. Okay. Just imagine if something like this is there and someone comes up and says union of 1, 2. So you'll connect like 1, 2. Next, someone will come and say union of 2, 3. So you'll like 2, 3. Next, someone will come and say union of 3, 4. So you'll be like. Next, someone will say union of 4, 5. So you'll be like. So what will you end up forming? A skew tree. This is known as a skew tree. What will you end up forming? A skew tree. And if someone now comes up and says, hey, does 4 and 5 belong to same component? If someone now comes up and says, hey, does 4 and 5 belong to the same component? Now, in order to figure out 4's ultimate parent, you have to go 1 step, 2 step, 3 step, and you'll figure out that the 4's ultimate parent is 1. In order to figure out the ultimate parent of 5, you'll have to go 1 step, 2 step, 3 step, 4 step. Hence, you'll figure out the ultimate parent of 5 is 1. So, thereby, it might take a lot of other time, right? Do you understand this? Do you understand this? Why do we always connect to something as the ultimate parent? Union of 2, 3 should be connected to. No, it's not mandatory. See, what I'm saying is, why did we connect to ultimate parent? I'm explaining that. Bharat, I'm explaining why did we do that? Because if we do not do, if we do not take 3 and connect it here, then a skew tree will be formed. Hence, we always took the ultimate parents and connected the ultimate parents. I'm telling you the reason. behind connecting the ultimate parents. I'm telling you the reason behind connecting the ultimate parents. Okay, so has everyone got it? Why do we connect ultimate parents and not like 2 and 3 को जोड़ा नहीं, 3 and 4 को ही जोड़ दिया, 4 and 5 को जोड़ दिया? Why are we not connecting the nodes itself? Because you might end up getting a skew tree. Thereby, it's very essential that you always connect the ultimate parent so that you form a very dense tree with a lesser height. Okay, so generally that's the reason. Now we'll come to optimizations. Yes, we'll. पैरा कट गया रे, सुबह से बैठा हूँ. ओ भाई साहब, समझ में आ गया सबको? The only reason we do not connect directly is because it will form a chain. So thereby, whenever someone says union of 2 and 3, you figure out 2 का बाप कौन है, 3 का बाप कौन है, दोनों को 2 का बाप कौन है, 3 का बाप कौन है, and दोनों को जोड़ दो. That's the only reason we do that. ठीक है? Got it? Okay. So we have understood. Yes, we have understood how the connection is being done and everything. Now, generically, the complexity is log n. If we do not do the complexity is still not log n. I will not say it is still log n, but yeah, we will do some optimizations. The first optimization that we will do is known as path compression. I'll come to code, don't worry. The first optimization that we will do is known as path compression. Okay, so in order to understand path compression, what I'll do is I'll probably in order to understand path compression, what I will do is I will probably take a better example. Let's do this. So assume n is equal to 8. Okay, assume n is equal to 8, and someone suddenly comes and says, hey, can you do a union of, yes, can you do an union of 2 and 3? So that will be something like this. Do you agree? Do you agree that will be something like this? If someone comes up and says union of 2 and 3, whereas 1, 4, 5, 6, 7, 8, everyone will be a single element, correct? Now if someone comes up and says, hey, can you do me a union of 1, 2? If someone now suddenly comes up and says, hey, I did not got the use of DSU. I told you, the use of DSU basically tells you if two different nodes belong to a same component or not, right? If you're given a graph like this, like for an example, if you're given a graph like this, how do you figure out if 3 and 4 belong to the same component or not? Like 3 is over here, 4 is in this component. This is component 1, this is component 2. How do you figure out does 3 and 4 belong to the same component or not? So for such use cases, something like a DSU is used. Okay? Perfect. Now someone is saying union of 1, 2. So can I say, if I say union of 1, 2, then we will end up having something like this. Don't you think we will end up having something like this? Right? We will definitely have something like this. Do you agree with this? I think everyone agrees with that. Everyone agrees with that, right? Okay, perfect. So after union of 1, 2, we will have something like this. Now let's move across and probably do union of 7, 8. Yes, we are doing a union of 7, 8. So what will happen is, first 7, 8 will be connected, and that will be something like this. Now someone suddenly comes up, yes, someone suddenly comes up and says, hey, why don't you do an union of 6, 7? So probably 6 will be there, and then a 7, and then 8 will be there. Okay. Perfect. And this time this will be this. Now someone suddenly comes up and says, hey, union of 5 and 6. So now we will have something like this, where this will go, and this will be like this. Now someone suddenly comes up and says, hey, union of 4 and 5. So don't you think still we are ending up forming a skew tree? Still we are ending up forming a skew tree. Don't you think? Still we are ending up forming a skew tree. Don't you think? Don't you think? I'll take the doubts afterwards. I will take the doubts afterwards. Thank you, Deepak. Thank you. I'll take the doubts afterwards. We are still ending up forming a skew tree. So this is the reason. Yes, this is the reason. Something like a path compression comes in. Something like a path compression comes in, so that you compress the tree. Something like compress the tree. Okay. Now let's understand. Now if I say union of 3 and like suddenly someone comes and says, hey, can you do me a union of 3, 8? Can you do me a union of 3, 8? So ideally, what will you do? You will say, hey, 3, who is your ultimate parent? hey 8, who is the ultimate parent? So in order to get 3's ultimate parent, what you will do is, you will go to 2, you will go to 1. Is that what you will do? Yes, and you'll get 1. And in order to find 8's ultimate parent, you will go 8 to 7, 7 to 6, 6 to 5, 5 to 4. You'll do that, don't you think? Don't you think you'll do that? Right? So this is where you can apply path compression. This is where you apply path compression. There's something you know for sure. There's something you know for sure. If 8's ultimate parent is 4, 7's ultimate parent is also 4. 6's ultimate parent is also 4. 5's ultimate parent is also 4. So remember one thing. If you're figuring out 8's ultimate parent, you have to actually figure out 7's ultimate parent, which means you have to figure out 6's ultimate parent, which means you have to figure out 5's ultimate parent, which is indeed 4. So can I say, okay, the moment you got 4, can I say, hey, why don't you do this? Like saying, hey, listen, 6 is there. I can definitely do that, because I know 6 ultimate parent is 4. Okay. Next, can I say 7? Hey 7, your ultimate parent is also 4. Perfect. Can I say 8? Hey, your ultimate parent is also 4. So can I say, when I went out to figure out, like this was something like this. When I went out to figure out 8's ultimate parent, I figured out कि 7 का भी वही है, 6 का भी वही है. तो सबको direct, can I just connect them directly, so that in the future, if someone comes and tells me, hey, give me the ultimate parent of 6, you don't have to again do like 6, 5, 4, or probably in the future, if someone says, hey, give me the ultimate parent, UP means ultimate parent of 7, you don't have to go like 7, 6, 5, because if you have figured out for 8, which means you have figured out for 7, which means you have figured out for 6. So can't you do some modifications, so that in future, if someone comes up and asks for 7 or 6, you don't have to again traverse and waste time, isn't it? Hindi mein main nahi padhata yaar. I don't teach in Hindi unless until you don't like, unless until I don't find words in English, I don't teach in Hindi. Sorry. Got it? Has everyone got it? Has everyone got it? So this is what is known as path compression. This is what is known as path compression. So can I say, whenever I'm finding out the parent of 3, can I say whenever I'm finding out the parent of 3, what does that mean? I'm saying 3 go here, 3 go here, and you found the parent 1. So 3 will now go and get connected directly to 1. So the moment you figure out 3's parent, it will come to be 1, 8's parent will come to be 4. And you can see this is the tree and this is the tree. So you have compressed the tree from a skew to a lesser size tree. You have compressed the tree from a skew tree to a lesser size tree. हाँ कर सकते हो आर्यंत, you can do it. As I said ना आर्यंत, तुम 1 को 2 से जोड़ो या 2 को 1 से जोड़ो, तुम्हारी मर्जी है. Yeah, self balance, like not self balancing, self adjusting height, मतलब बैलेंस नहीं कर रहा है ना ये. बैलेंस इज समथिंग व्हिच यू से लेफ्ट एंड राइट इक्वल होता है. इधर लेफ्ट एंड राइट नहीं, ये छोटा कर रहा है. जितना बड़ा था वो छोटा कर दे रहा है. क्यों? बड़ा का मतलब क्या है? इसका अल्टीमेट पैरेंट ये होगा, तो इसका अल्टीमेट पैरेंट ये होगा, इसका भी ये होगा, इसका भी ये होगा. तो बंदे ने क्या बोला, भाई मैं इसका निकाल रहा हूं तो इन सारे का भी तो निकल जाएगा, राइट? तो सारे को जोड़ दो सीधा. বেঙ্গলিতে পড়াতে পারবো না, সরি বেঙ্গলিতে পড়ালে কেউ বুঝবে না, তাই আমাকে হিন্দিতে বলতে হবে, বুঝেছিস? Okay, cool. So now whenever someone says 3's ultimate parent is 1, 8's ultimate parent is 4, so what will you do? The connection will be like 1, 2 is there, 3 is there. Now you'll take this 4 and you'll say, hey 4, why don't you go and get connected to this guy? This is how the connection will look like. This is how the connection will look like. After the connection happens of union of 3 and 8. Did you understand this? Does everyone understand this? Does everyone understand this? Yes or no? UQ? Yes. Yes मिहिर, yes. तुम किसको जोड़ते हो उस पर डिपेंड करता है. Has everyone understood this? UQ please. UQ please. Okay, UQ everyone. Okay, someone is saying, Saurav is saying again. Okay, Sumit is saying again. देखो क्या है? How was it? There was a 3, there was a 8. So how was it like? देखो कैसा था? 4, 5, 6, 7, 8. ठीक है. तो you know one thing. For this 8, the ultimate parent is 4. For this 7, the ultimate parent is 6. For 4. For this 6, the ultimate parent is 4. For this 5, the ultimate parent is this. So what you did was, you said अगर 8 का निकालना है तो ऐसे जाना पड़ेगा, ऐसे ऐसे ऐसे. तो भाई मैं सबका ही तो निकाल रहा हूँ, 4 है. तो एक काम करता हूँ ना, जब निकाल ही रहा हूँ तो 6 को बोल देता हूँ, 6 भाई तेरा पेरेंट जो है ना वो 4 है. 7 भाई तेरा पेरेंट जो है वो 4 है. 8 भाई तेरा पेरेंट 4 है. मैं सबको बोल दिया. मैं निकाल तो रहा हूँ 8 का निकालूंगा तो 7 का भी निकालूंगा, 6 का भी निकालूंगा, 5 का भी निकालूंगा. तो मैंने क्या बोला, अरे भाई सबको ही का पेरेंट 4 ही है. निकाला है तो सीधा जोड़ ही दो ना, क्योंकि अब नेक्स्ट बार वापस कोई मेरे को पूछेगा भाई 8 का बता कौन है, फिर मैं 8 से 7 जाऊंगा, 7 से 6 जाऊंगा, 6 से 5 जाऊंगा, 5 से 4. समय की बर्बादी है ये, है कि नहीं? अगर एक बार में मेरे को पता चल जा रहा है, अगर ये पहला बार में ऐसा है कुछ, पहला बार कुछ ऐसा है, पहला बार कोई 8 का पूछा, मैंने 4 बताया, फिर 8 का पूछेगा तो फिर से जाना पड़ेगा, फिर 8 का पूछेगा तो फिर से जाना पड़ेगा, फिर 8 का पूछेगा तो फिर से जाना पड़ेगा. समय की बर्बादी है यार, सीधा जोड़ दो ना सबको. गॉट इट? हैज एवरीवन गॉट दिस? हैज एवरीवन गॉट दिस? सबका मालिक तो एक ही है. किसी ने सिद्धार्थ में, सबका मालिक एक है, सबको बोल दो ना तुम्हारा मालिक ही है, और वापस क्यों तुम घूम के रास्ता करोगे, राइट? Okay, so everyone has understood. Okay, so this is how the state will look. Now suddenly someone comes up and says union of 7, 3. So this time what will happen is, you will say, hey 3, your parent is 1. So already 3 का मालिक 1 ही है, तो कोई path compression नहीं होगा. But 7's मालिक is 4, 4's parent is 1. So 7 will say, hey, I will do a path compression, and what I'll do is, I will say 7 will do a path compression, and 7 will say I'll get directly connected to this, because 7 found out its ultimate parent 1, so there was a path compression, and we figured out that they belong to the same component, so there is no need to connect them. They already belong to the same component, so there is no need to connect them. Next, if someone comes up and says union of 6, 1, so you'll take this and you'll connect it here, again a path compression. Got it? So this is how you do the path compression. Yeah, I'll do the problem. Yeah, they belong to the same component. So no union, because they belong to the same component. So has everyone understood the path compression? सुरेंद्र is saying, ऐसे compression करते करते एक बाप का बहुत बच्चा हो जाएगा. Exactly. Yeah, I'll do problems, don't worry. Aniket, I'll do problems. Now tell me one thing. Did you observe something? एक चीज नोटिस किया क्या? अब जब 7 का निकाला ना, जब तुमने 7 का बाप निकाला, तो 7 को सिर्फ एक स्टेप जाना पड़ा. और पहले कितना स्टेप जाना पड़ता अगर मैं पाथ कंप्रेस नहीं करता? 7 को 1, 2, 3 और एक स्टेप, इतने स्टेप्स जाना पड़ते हैं. और तुमने पाथ कंप्रेशन किया तो ट्री इतना छोटा बन गया कि सिर्फ कम स्टेप्स लेना पड़ रहा है. Got it? Ayush can't help. This is a place where I teach live, where I interact and teach. A lot of people watch recordings and they have a lot of doubts. So over here I clear doubts. So yeah, probably if you feel that you're wasting time, what you can do is, the best suggestion that I can give you is, probably don't watch live. Once the live gets uploaded, come out and just scroll and watch. That's the best opinion that I can give you. Okay, so we have done this. Okay, path compression is done. Now there's still a problem. What problem? There's still a problem. अभी जब ये जुड़ा एक चीज नोटिस करो. जब जुड़ा था, कैसे जुड़ा था? 1, 2, 3, 4, 5, 6, 7, 8. This is how it connected. Do you agree? This is how it connected. This is how it connected. अभी भी कितने बच्चों को ज्यादा स्टेप्स लेना है? ये 5 को अभी भी 6 has to still take a step, 7 has to still take a step, 8 has to still take a step. Don't you think if I would have connected it the other way, I would have connected it the other way, which means I would have kept 4, yes, I would have kept 4, and I would have connected 1 to 4. Then the number of guys whose ultimate parent was different would have been different. Like there are two guys for which the ultimate parent has to be taken 2 steps, and over here there are 4 guys whose ultimate parent has to be found out by taking 2 steps. So which tree is logically, like intuitively better to take? This one or this way? This one or this one? What do you think? Which one? Yeah, logically see, यहाँ पे 5 का बाप निकालना पड़ेगा, 6 का भी बाप निकालना पड़ेगा, 7 का भी बाप, 8 का भी बाप, एंड काफी स्टेप्स लेके निकालने पड़ रहे हैं. इधर सिर्फ 2 का बाप निकालना पड़ रहा है क्योंकि बाकी लोग तो सीधा कनेक्टेड है, सिर्फ 2 बंदों का बाप निकालना पड़ रहा है और यहाँ पे 4 बंदों का. तो लॉजिकली टू सेव टाइम 2 बंदों का बाप निकालना ही तो बेटर रहेगा ना इन लॉन्ग टर्म. सो दैट्स व्हाई डोंट यू थिंक connecting the smaller size to the bigger size is sensible? Connecting the smaller size to the bigger size is sensible. This is what we call as union by path compression plus size, or you can call it as union by path compression plus size compression. There is something which is known as rank also, but yeah, union by path compression by size compression. Okay, size matters. Yes, size matters, right? Isn't it? Cool. देखो, छोटा बड़े में जाएगा, कॉमन सेंस, छोटा बड़े में जाएगा, है कि नहीं? ऐसे याद रखो, छोटा बड़े में जाएगा, नहीं तो फिर नहीं जा पाएगा. बड़ा तो छोटे में जा नहीं सकता, है कि नहीं? लॉजिकल, राइट? Funny, right? Okay, cool. So everyone has understood, right? So everyone has understood union by path compression and size components. Now we will move across to code. This is a very, very simple code, like very, very simple code. Okay, that's very, very simple code. So generally I will always recommend you, if you are doing a code, like if you are coding in interviews, always do interview kind of codes. So class DSU, I'll teach you class ka bahut easy. So always have a class. Okay, always have a class and have a private variable, or like int, like you can keep a vector of int of parent. Okay, and there is other thing, that's size, that is which you'll require. Okay, I'll teach you how to do this, don't worry. I'll code the entire thing. This is a production level code that I'm writing. इंटरव्यूज में ऐसे करोगे ना, इंटरव्यू बोलेगा आ भाई गले लग जा मेरे, मैं बता रहा हूँ, ऐसे ही करना. मतलब लाइक आ भाई तू पक्का अभी आ गले लग जा मेरे. So please make sure you code it like this. Please make sure you code it like this. ठीक है? Okay, so DSU, you'll create a constructor. So this is a class, this is a constructor. In the constructor you'll say कितना साइज का है रे भाई, तो कितना साइज का है, अच्छा इतने साइज का है. चल, what's the first thing that you'll do? You will say everyone is the parent of himself. Assuming one based indexing, I am saying parent dot push back of I, size dot push back of 1. So initially everyone is single, right? So you have something like this. So probably over here what you can do is void solve DSU equal to obj, right? You can probably keep DSU ब्रैकेट में तुम लिख सकते हो द साइज वॉट एवर यू वांट टू क्रिएट, प्रॉब्ली साइज n है तो n लिख दो. सो व्हाट विल हैपन इज इट विल ऑटोमेटिकली क्रिएट दैट मच साइज. यस, इट विल ऑटोमेटिकली क्रिएट दैट मच साइज. ठीक है, कोविड है गले कोविड है, किसी से गले मत लगो. ये समझ में आया क्या? ये समझ में आया एवरीवन? Has everyone understood this? Has everyone understood this? Yes, बोल दो. मतलब क्लास थोड़ा क्लास है बट इजी है, मतलब उतना भी टफ नहीं है. इट्स वेरी इजी. डोंट कॉम्प्लिकेट, एज आई ऑलवेज से. डू नॉट कॉम्प्लिकेट स्टफ. अच्छा अच्छा, जावा नहीं कर रहा हूँ. सॉरी, माय बैड. आई एम नॉट डूइंग जावा. माय बैड. In over here you'll declare it like this. Okay, so what I've done is I've declared a DSU. So I have a DSU ready. Now what do I require in the DSU? I require a union function. So we will have a union function, and I also require something. Probably this will be a public function, so you can keep it as public. And I will require another public of a get parent function. बाप पता कर भाई, कौन है बाप पता कर. चल. So find parent, int find parent. Okay, this is something which I will have like int of find parent. So how will the find parent get executed? Like if I ask you how will the find parent work, can someone tell how will the find parent work? Now that's very simple, very simple. So what you will say is, if like there will be a node that is given to you for whose you have to find the parent. So if the parent of node is equivalent to node, you will say कि यही बाप है. अगर ये खुद का बाप है तो यही ultimate है. So this is the parent. If he is himself the parent, you'll say he is the parent. Otherwise you will say return parent, like find parent of parent. चलो ऊपर जा, ऊपर जाके खोज. इसका ऊपर जा, इसके ऊपर जा, ऊपर जा जाके खोज. बट जब खोज लिया है तो भाई जो तुझे मिला अल्टीमेट, मैं भी मेरा अल्टीमेट. अब वो मेरा बाप, मैंने बाप चेंज कर लिया. देखो मैं यहां समझाता हूं. यहां था, देखो 4 था, 5 था, 6 था, 7 था, 8 था. 8 ने बोला, ओ भाई 8 ने बोला जाके खोज. 8 किसमें खोजेगा? पेरेंट ऑफ 8, दैट्स 7. Where will 7 find? Parent of 7, that's 6. Where will 6 find? Parent of 5. Where will 5 find? Parent of 4. So whenever you go to 4, you see 4 is pointing to himself. You will say 4 is pointing to himself. So whenever it points to himself, it will return that 4. So the moment it returns 4, a 5 बोलेगा, अरे मेरा बाप अब 4. So 5 का बाप 4. 6 बोलेगा 4 मिला मेरे को, मेरा बाप भी 4. 7 बोलेगा, सॉरी 7 बोलेगा मुझे भी 4 मिला, मेरा बाप भी 4. 8 बोलेगा मुझे भी 4 मिला, मेरा बाप भी 4. सो दैट इज व्हाट आई एम डूइंग ओवर हियर. जो बाप मिल रहा है उसको लगा दो. सो गॉट इट? Has everyone got this? Okay, so we have बाप तो कर लिया, we have done find parent. We have to do void union. So how do you union it? That's very important. How do we union it? Now something I know for sure is दोनों का बाप बराबर. Like I will get two guys. UV which I have to connect. I know one thing. First I need parent of U. So find parent of U. Let's call find parent of U. Let's call find parent of V. So one thing I know for sure, if the parent is equal, no need to connect them. वापस जा. अरे भाई same बाप का है. You are of same parents. Why do you want to get more connected? So you will say go back. Yeah, I'll come to find parent complexity. You will say go back. Okay. Now coming to if they are not different, then size matters. So you will say size of PU, is it smaller than size of PV? तो PV बड़ा है तो छोटा जाके बड़े में लगेगा, तो parent of PU जाके PV में लगेगा. Got it? If PU is small, the small gets connected to the bigger, and if that happens, PV में connect हुआ, so PV size will increase, and the opposite, parent of PV will get connected to PU, and size of PU will increase by size of PV. Got this? This is how you will do union. So size matters. Okay, so has everyone got this? Has everyone got the union function? Has everyone got the union function? So I've written a production level code where we have a DSU ready. We can use this in every code that we do. We can use this in every code that we do from now onwards. Is it clear? Size is same as rank. I'll come across to rank. Don't worry. I'll come across to rank. This is something which is known as union by size. अरे ठीक है, बाद में लड़ाई करना, ये समझ में आया? Have you understood this? Has everyone understood this? I'll tell you क्या फायदा होता है ऐसे कोड लिखने का. बहुत easy readable होता है. It's very readable and you can just use it again and again and again. So what I'll do is I'll just copy paste in every question now, because I've written it in a very optimal way. I've written it in sense of n. I've made sure that it's a DSU. Doesn't matter what is your input. If I just have the n, how many number of nodes, this DSU will always work. So I have written a class which works for all the problems of DSU. I don't have to write DSU again. I've written a class in such a way. Okay. Yeah, this is where you update the size vector. Okay, let's understand. So parent ka to easy hai. If the parent is node, then you call, okay, node is the answer. Or what you do is, to baap ko bulaya, you just call it again and again, recursion. And whatever it returns, you just store it. So this is where the path compression is done. Remember, if you do path compression, that makes the size of the tree to be log n. So hence the complexity becomes big O of log n. Because if the log n is the height, then in order to find the parent, you have to go log n distance. In order to find the parent. Got it? So if you're using path compression, the complexity is log n. Okay. But if you use path compression and size, then the complexity becomes big O of 4 cross alpha, where alpha is as small as 1. Like alpha is very small. And please don't ask me the proof. Iska proof मतलब 100 page का पढ़ लेना अगर मन है तो. Like generally it has been seen, if you connect chota to bada, the path compression takes place in, like, the complexity of the entire stuff becomes 4 cross alpha, which is 4 alpha, which is as good as a constant time. यूनियन कोड रिपीट कर देता हूं, देखो यू आया, सो इट्स सेइंग एक नोड दूसरा नोड. तो मैंने क्या बोला, तू अपना अल्टीमेट बाप निकाल, दोनों के बाप बराबर, डोंट डू यूनियन, गो बैक. ओवर हियर व्हाट आई डू इज पीयू छोटा, पीयू को जोड़ पीवी में, हो गया. सो पीयू को बोलेगा, ए पीयू अब तेरा बाप पीवी, पीयू तेरा बाप पीवी, चल जुड़ गया. अब पीवी में जुड़ा, पीवी बोला ओ भाई कोई जुड़ गया, मेरा साइज बढ़ जाएगा. तो मैं क्या बोला, ओ भाई साहब मेरा साइज बढ़ गया, तो मैंने साइज जोड़ दिया. जितना जुड़ा उसका साइज बढ़ेगा ना, पीवी का साइज बढ़ेगा ना, तुम जोड़ रहे हो किसी को तो बस. और इस तरह उल्टा आया. यूनियन समझ में? हैव यू गॉट यूनियन एंड रैंक बोथ? हैज एवरीवन गॉट दिस? 2021. Then proof is not necessary for this question. 4 alpha ka proof is not necessary. Okay, is it clear to everyone? Everyone has understood this? Okay. वर्ड सर्च प्रॉब्लम, अरे भाई अभी थोड़ी करेंगे डीएसयू के स्ट्रीम में वर्ड सर्च प्रॉब्लम क्यों ले आ रहे हो? ओके, दिमाग में पूरा सेट हो गया डीएसयू, दिमाग में सेट हो गया. अब बताते हैं व्हाट्स अ यूज केस. अ लॉट ऑफ टाइम्स यू विल से, दे विल से यू, सो लेट्स डू वन एल्गोरिथम. So by the way, let's do so there is another technique which is known as union by rank. Okay, so probably you can read that afterwards. I'm not a big fan of rank. You can read that if you want to read. On my channel you'll find this. I'm not a big fan of rank. If you want to read it, you can read it. But if you know size is very intuitive. Rank is not intuitive. Rank बोलता है कितना बार जोड़ रहा हूँ वो गिनो. एक बार जोड़ रहा हूँ प्लस प्लस करो, 2 बार जोड़ रहा हूँ प्लस प्लस. Rank is rank is bogus. So चल कर दो rank. If you know this works fine. If you rank खुद पढ़ लेना, ठीक है? Yeah, complexity is 4 alpha. Dhruv, the complexity is 4 alpha. Yeah, the complexity is 4 alpha. So we'll do one algorithm where we will see how is this implemented. Okay, we'll do one algorithm where we will see how is this implemented, and then probably I'll give you a Google question, and then we'll move across. ठीक है? Rank size rank दोनों करो बराबर है. It's nothing like you. If you just read, पता है difference क्या है union by rank का? मैं union size लिख देता हूँ इधर. Union by rank मैं बता देता हूँ क्या है. सेम ही है बस थोड़ा सा चेंज हो जाता है. It's the same. What they do is in rank, what they do is they create one more. Okay, in rank what they do is they basically keep a rank and basically say कि कितना ऊंचा है, but वो logical नहीं है. That's not logical. You can watch it on my channel. I'll not add it over here. थोड़ा सा confusion हो जाएगा, but you can watch it on my channel. But it's not logical or intuitive. Okay. Yeah, 4 alpha. Rank is also 4 alpha. Size is also 4 alpha. Both of them are 4 alpha. Okay. रैंक मैंने अपने चैनल पे पढ़ाया था, साइज इधर पढ़ा दिया, तो दोनों मिक्स करके सब कुछ सीख गया. तो ठीक है, चेकआउट कर लेना बाद में, बट इट्स इजी. बोथ आर सेम. आई एम समवन व्हिच फॉलोज साइज. A lot of people follow rank. It's okay as long as you do it. बोल रहा हूँ तो बता ही देता हूँ. लोग फिर बोलेंगे फिर नहीं बोला, तो मैं बताता हूँ. देखो क्या होता है. What you basically do is you keep a rank. Okay, you keep a rank. So initially everyone's rank is 0. Remember this. Initially everyone rank is 0. So what I do is initially I say everyone's rank is 0. Initially everyone's rank is 0. Assume I say, hey, can you please do a union of 1 and 2. So if you're doing a union of 1 and 2, so that means you're connecting 1 and 2. So you're basically saying 1 2 se juda. Hence the rank of 1 will increase by 1. So you increase the rank of 1. Now if someone says, hey, can you do me a union of आदत खराब हो गई. ओके, चैट देखा अभी देखा. मैं पर बता देखो, लेट्स बता ही देता हूँ. चलो, so if I say union by rank and assume the number of nodes are 7. Okay, assume the number of nodes are 7. So what I do is I say, let's take a rank array which is of 7 size. Let's take a rank array which is of 7 size, and initially keep everyone as 0. Okay, and initially keep everyone as 0. Okay, now you can see. So now what I'll do is I will say, let's assume I am doing a union of 1 comma 2. So you know the concept of parent. So just introducing a rank. If 1 is connected and 2 is connected, you figure out the rank of both. So what you are saying is rank of 1 is 0, rank of 2 is 0. So if both the ranks are same, किसी को भी किसी में जोड़ो. Size don't, like, assume it to be as a size, treat it as a size. किसी को भी किसी में जोड़ो. तो I say let's connect 2 to 1. So you will say, okay, 1's rank will increase by 1. Okay, next I say union of 1 comma 3. Let's assume 2 comma 3. I say union of 2 comma 3. So you will say, okay, 2 का ultimate parent कौन है? Who's 2's ultimate parent? It's 1. Who is 3's ultimate parent? It's 3. So you write the ultimate parents, and again you'll figure out the rank. The rank of 1, yes, the rank of 1 is 1. The rank of 3 is 0. So if the rank is bigger, if someone has a bigger rank, so you will say there's no need to increase rank. Let's just connect 3. So rank basically gives you a subtle idea about which is the larger and which is the greater instead of size. Rank is something which gives you a specific idea about which is the greater size. Got it? Depth मैं बोलूंगा नहीं, क्योंकि जब path compression होता है, we will not call it as depth, because when you do a path compression, rank is not decreased. So we cannot call it as a depth. Okay, let's go across and understand in much depth. Don't worry. So let's assume I'm saying union of 5 6. Okay, so let's do union of 5 6. So if I do union of 5 6, 5's rank is 0, 6 rank is 0. So you can connect anyone to anyone. So assume 5 is connected to 6. So 5's rank is increased to 1. Okay. Next, assume I am saying connect 4 to 5. Connect 4 to 5. So you will say 4 to 5. 4, 5. 4's rank is 0. 5's rank is something which is 1. So you will connect 4 to here. Again, rank will not be increased. Now, this is the moment you will understand a fair bit of idea why rank is not the depth. Why rank is not the depth. Now suddenly someone comes up and says, hey, can you connect 2 and 6? Can you connect 2 and 6? So who's 2's ultimate parent? That's 1. Who is 6's का ultimate parent? 5. Rank क्या है? 1 का rank क्या है? 1. 5 का rank क्या है? 1. Both of them are of same rank. So both of are same size of tree. So what you'll do is you'll just connect them. So rank is not the depth. Rank basically gives you a fair bit of idea about which is the larger tree. That's it. Rank is not depth because now the depth is 2. But you did not increase. By the way, rank increase करना है. Sorry, rank increase करना है. Rank increase करना है 2 को. But logically समझ गया ना मतलब it will not give you the depth idea because assume. So rank will be 2. If the rank is equal, you increase the rank. So rank is 2. Now let's understand why this rank does not gives you the idea of depth. Someone says union of 6, 7. Someone says union of 6, 7. Someone says union of 6, 7. क्या होगा बताना? सब बताओ तो union of 6, 7 करेंगे तो क्या होगा? Union of 6, 7 करेंगे तो क्या होगा? 6 का parent निकालूंगा. क्या आएगा? क्या होगा? बताओ. क्या होगा? बताओ. If I say union of 6, 7, what will happen? बताओ. Tell me. What will happen if I do a union of 6, 7? What's the first step? 6 बोलेगा. 6 will say, who is my ultimate parent? Right? So what will happen? A path compression will happen. So 6 will say, now I have this. Similarly, when I say for 7 will also do a path compression. Now what's the height of the tree? So both of their parent come out to be 1, so you will not connect them. So what's the height of the tree now? 1. But the rank is still 2. So basically rank is giving you an idea which is the larger tree, but if path compression happens in between, then the rank will never give you the depth. Got it? Have you got this? Why I can say कि rank is not the depth? Because कभी path compression हुआ tree छोटा हो जाएगा, but rank छोटा नहीं हो रहा है उस moment पे. Path compression पे tree छोटा होगा, but rank वही रहेगा पुराना वाला. इसलिए rank is necessarily not the height of the tree. Got it? पाथ कंप्रेशन कोड में हो रहा है ना, ये रहा, यहाँ पे हो रहा है. जोड़ दिया ना सीधा जो अल्टीमेट बाप था उससे. So has everyone understood? You can do anyone. Has everyone understood this? Has everyone understood this? EQ. अरे भाई DSU कोड तो दिया हूँ, नशा करके आया हो क्या? ये क्या है? सो रैंक भी जोड़ देना. सो रैंक इनिशियली विल बी 0. Rank initially will be 0, and if I do a union by rank, so let's copy paste. So I'm also writing the rank. ठीक है? ये ऋषभ को कोई समझाओ भाई. कोई ऋषभ को थोड़ा समझाओ. Okay, so we do a union by rank. So what will happen is, now instead of this, you will say rank, else if it's the opposite, rank of PV is greater than rank of PU. Sorry, rank of PU is greater than rank of PV, or ulta. Rank of PV is smaller than rank of PU. ठीक है? अच्छा, ID1 का लिंक तो लास्ट में दे देता हूँ. अभी तक क्या क्लास नहीं किया क्या सारे? Okay, so Now what will happen is, instead of rank, so rank will now not be changed. याद है जब बड़ा और छोटा जुड़ता था रैंक नहीं चेंज होता था, बट जब बराबर के रैंक जुड़ते थे, किसी को भी किसी से जोड़ दो, बट इस मोमेंट पे रैंक को बढ़ा दो पीवी का, क्योंकि पीवी में जुड़ा है. So if the rank is smaller, then just connect, no need to increase rank. If rank is if it's smaller, then just connect, no need to increase. But this means rank is equal. In case of equal, then increase. Same complexity. Okay, has everyone understood the union by rank, union by size, the path compression, find the parent, and everything else? And I've written a wonderful class. You can use it again and again. EQ for everyone? Everyone EQ, right? Okay, everyone has understood this. Perfect. Super. I'm not a big fan of swap. I don't use. This is something readable. Thereby, swap is something which is not preferable in industry-based coding. Or if you are giving an interview, don't use swap. It's okay for competitive programming, but if you're giving an interview based, don't use those kind of things, because generally what happens is they will kick you out. Always try to write codes like this. If you're giving Google interview, कहीं भी दे रहे हो तो code ऐसे लिखो so that readable. Code should be readable. Okay. कोई इसको बताओ, ये क्यों क्या है, कोई बताओ सुहास को, कल से पूछ रहा बेचारा. Okay, so you've understood this. Okay, now we'll do a wonderful question on lead code probably. As a ILNs 2. Again, you will not find this question. This is a premium question. So probably link क्या बोलते हैं उसको, lint code use करो. Probably you can use lint code. Yeah, you can use lint code to do this. Number of islands 2 is the question. You can definitely use lint code. There's a question, मैंने इसको solve करके रखा है, but अभी के लिए हटा देता हूँ. Okay, here's the question. It's a lead code hard. So कोई बोलना मत भैया तो से पढ़ा के चलेगा, lead code hard कर रहा है, मजा आने वाला है. I want to enjoy this. So I wanted to read the question. Definitely I wanted to read the question, and probably after that we can start thinking of how to solve this or whatever we are willing to. Okay, yeah, read the question. I'll also read the question. Question भूल गया. Okay, wonderful question. Okay, looks like a very good question. No, lint code, not lin code. Lint code. Lead code hard, please. I was asked in Google probably, if I'm not wrong. Just asked in Google, I'm for sure. Yeah, as that in Google, Uber, Apple. I said no, the Google का question है. Google interview questions are generally of lead code medium and lead code hard level. Like थोड़ा medium का higher level and hard का थोड़ा नीचे वाला. Hard का extreme hard नहीं, hard का नीचे वाला and medium का ऊपर वाला. समझ, मीडियम का भी दो कैटेगरी होता है, एक बहुत इजी वाला मीडियम होता है, एंड एक जो मीडियम होता है सही में लगता है कि मीडियम नहीं है वो वाला, एंड हार्ड में कुछ ऐसा होता है कि लगता है कि ये हार्ड शायद नहीं होना चाहिए था, मीडियम हो सकता था वो वाला. ठीक, यूबर ज्वाइन कर लो आप. नो, आई एम नॉट इंटरेस्टेड टू ज्वाइन एनीवेयर एज ऑफ नाउ. आई एम वेरी हैप्पी वेयर आई एम. आई गेट अ लॉट ऑफ लग्जरी टू डू ऑल माई फ्री वर्क. दैट इज व्हाट आई पर्सनली वांट. आई डोंट वांट टू गेट टू अ कंपनी व्हिच पोक्स नोज लाइक सब में नाक कोई डालने वाला. मुझे वैसा कोई कंपनी नहीं चाहिए. तो फिर मेरे को भी वीडियो बनाना पड़ेगा है कि नहीं, सिनेमैटिक शॉट्स के साथ. तो आई डोंट वांट दैट टू हैपन. आई एम वेरी हैप्पी वेयर आई एम एज ऑफ नाउ. How important is binary lifting? No, not important. For not important. मैं मजे नहीं लेता, मैं फैक्ट बोलता हूँ. नॉट कॉन्ट्रोवर्सी. देखो मजे नहीं है यार, देखो इट्स फैक्ट. जो फैक्ट है वो है. हम लोग, मैं फर्स्ट ईयर में तो हूँ नहीं कि आप मुझे कुछ भी बोलोगे मैं सुन लूंगा. तो या दैट्स इट. It's just about what I feel and what not only I, what everyone feels who's matured enough. Simple. नहीं यार, सब्सक्राइबर्स, लाइक टू बी वेरी ऑनेस्ट, आई एम अप दैट लेवल जहाँ मुझे सब्सक्राइबर्स बढ़ाने हैं. आई वांट टू हेल्प पीपल, दैट्स इट. आई एम नॉट ऑन दैट लेवल जहाँ मुझे सब्सक्राइबर बढ़ाने हैं. सी, earning money will be there. I will not deny that. But see, if you see this channel, there are a lot of other people who are teaching and वो follow linear search, binary search, bubble sort पढ़ाते हैं. I can also teach that and I'll still get paid. Don't worry. If I teach that, I'll still get paid. But yeah, probably I solve lead code hard. I solve, मैं streams करता हूँ, Amazon interview experience, Google interview experience solve करता हूँ because I enjoy it. I enjoy it and probably आप लोग भी कुछ सीख के जाते हो. I also get paid. That's okay. And probably आप भी सीखते हो तो मुझे भी मजा आता है, मेरी प्रैक्टिस हो जाती है. That's it. It goes together, right? Cool. Let's solve this problem. You generally count subscribers when you are at 10,000. In that sense, when you cross 1 lakh, I don't think anyone counts subscribers. After that, it's just a number. Like it will hardly matter जब तक फिर वो 1 million के आसपास होगा, फिर थोड़ा मैटर करने लगेगा कि सब्सक्राइबर बढ़ाओ. बट वो 1 लाख के बाद फिर क्या होता है, हाँ भाई अब क्या ही बढ़ेगा, बढ़ने तो जो बढ़ना है, वैसा वाला फीलिंग आती है. अब कितना ही बढ़ लेगा. ऐसा सिमिलर वाला एक कुछ दिन पहले एक इंटरव्यू पूछा था आपने, राइट? हाँ, that's actually true, Devesh. If I teach, first thing is I am always prepared. The second thing is I am in touch with data structure algorithms. So बहुत अच्छा टच है मेरा भी. अगर मुझे आप मुझे कोई भी इंटरव्यू मेरा ले लो तो I'll probably crack it. If I give 10 interviews, I'll probably crack 7 or 8. I'll not crack 10, but probably I'll crack 7 or 8. That much confidence I have. Okay, let's understand the question. 146 watching. कहाँ थे इतने लोग? आज कुछ था क्या? Contest वगैरह था क्या आज? Was some question today or what? हाँ, ये क्वेश्चन चलो करते हैं. हाँ भाई, मैं करवा के जाऊंगा यार. Okay, I'll do that. चलो क्वेश्चन करते हैं. क्वेश्चन समझते हैं पहले. लेट्स फर्स्ट अंडरस्टैंड द क्वेश्चन. तो पहले मैं क्वेश्चन फटाफट लिख लेता हूँ, तुम लोग थोड़ा क्वेश्चन पढ़ लो. तो मैं फटाफट क्वेश्चन लिख लेता हूँ. बाय द वे, ये मेरे को पहले बताएगा ये कौन है भाई जो मेरा शॉर्ट्स बना के डालता है. मतलब अयो मेरे साथ व्यूज लेते हैं शॉर्ट्स बना के. ये पहले बताओ यार कौन है. मैंने बंदे को रीच आउट किया, बंदे ने नाम नहीं बताया. बंदे ने बोला भैया मैं डालता हूँ, कोई दिक्कत हो तो बताना. तो मैं उसको रीच आउट किया, भाई ये क्या टाइटल्स यूज करें. रिप्लाई नहीं किया बंदे ने. ओके, लेट्स अंडरस्टैंड द क्वेश्चन. So generally you'll be given a 0 cross like a 3 cross 3 grid. ठीक है, you will just get a 3 cross 3 grid. ठीक है. So you will be said that okay, let's understand. Islands are formed if it is something in the direction of this, then the islands will be formed. Okay, if it is in this direction, then the islands will be formed. So the first island, where they're saying okay, there is the first island is at 0,0. So this is where the first island is at 0,0. So right after the first query, in the entire grid, how many number of islands are there? There is only one island. So you will say the answer is 1 after first query. Let's do the second query. So if I perform the second query, which is 0, 1, this will be 1. So after the second query, how many islands are there? There are 2 islands. after the second query, sorry, there is one island. Sorry, there is exactly one island, because they are saying that if islands get connected together, they will be considered as a single piece. So what I can say is, even after the second query, there is only one island. Okay. Next, there is 1 2. So 1 2 means this portion. 1 2 means this portion. ये मैं थोड़ा क्वेश्चन गलत समझा क्या? नहीं 1 2 अच्छा sorry 1 2 means ये वाला, my bad. 1 2 means this portion. So I am saying after the third query, how many islands are there? Now as I said, islands will only get connected according to this portion. So this is an island. So two islands get connected to one, but they cannot connect diagonally. So this is a separate island. So there are two islands after the third query. There are two islands after the third query. So there are two islands after the third query. Let's do the fourth query. So we have a fourth query and it says 2 comma 1. So this is 2 comma 1. So I put a 1 over here. So after this query, I can say this is one island, this is one island, and this is one island. So in total, I have again two islands. So this is what they want. After every query, how many number of islands are there? Have you understood the question? Question समझ में आ गया? Question आया समझ में? Have you understood the question? Question आया समझ में? Remember, if they're adjacent, or if they're up or down, you can connect them to single. Right? Got this? Shouldn't it be 3 islands? Oh yeah, it'll be 3 islands. Sorry, it'll be 3 islands. It'll be 3 islands. Yes, it'll be 3 islands. Let's do one more example for people who have और example है क्या? नहीं और example नहीं. Okay, so I hope you have understood. So if I just expand this question and probably I give you a fifth query where I say that, hey, listen, probably in the fifth query I will say that, why don't you keep something at 2 comma 2? So that means you're saying this is where another island is. So can you say me after the fifth query, what are the total number of islands that I have after the fifth query? It will tell you after the fifth query how many number of islands are there in total. Can you tell me quick? Three, yes. 1, 2, 3. Right? This is 1, this is 1, and this is 1. There are 3 islands after the fifth query. So if I just change it and I say sixth query and I say that, hey, can you tell me what are the number of islands? So if I say let's put something at 2 comma 1. So this will be 1. Now can you tell me how many number of islands are there? Can you tell me how many number of islands are there? How many number of islands are there? 2, yes. Because this is 1 and this is 1. So there are 2 islands. There are 2 islands. Right? There are 2 islands. Got it? They all will get combined. They all will get combined. All of these are single island. And this will be another island. So abhi question sabko clear hai? The question is clear, right? Okay, perfect. So how will you solve this problem? How will you solve this problem? Because the main problem over here is if I next say at 1 comma 1 I put, this guy will get connected to 2 different islands now. 2 different islands will get connected. Do you see? And ek ho jayega. If I put it something like this, if I put it 1 comma 1, this will get connected to this and this will get connected to throughout. So दोनों को जोड़ दिया, 2 components को जोड़ा अब इसने 2 component को जोड़ा. कैसे करोगे बताओ मुझे. How will you do this? How will you do this? Tell me. Okay, DSU for every node, but that will take a lot of time if you do it for every query. Don't you think if you do a DSU for every node that will take a lot of time? I think yes. Can you think this as a graphical question? Can you think this as a graphical question? Can you think this as a graph question? Yesterday, did I tell you a technique of something like I into M plus J is how you convert a 2D to a 1D? Remember yesterday technique, I into m plus j. How do you convert a 2D into, right? Yeah, this is something which I told you yesterday, right? How will you do this? How will you do this? Any idea how you do this? Okay, let's understand how you do this. So, you know DSU, right? It's gonna be a good question, so it might take some time. But yeah, after you are able to solve this, you'll be like, wow. So assume one thing initially, guys. Everyone is a parent of itself. Okay, everyone is a parent of itself. Okay, but everyone is not an island. But everyone is not an island. So everyone is 0 initially, and everyone is itself a parent. So logically, this is like 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So if you want to do it as a 1 based indexing, probably you'll do it like I into m plus j plus 1. If you do this, then the 1 based indexing can be done. If you do this, then the 1 based indexing can be done, and you can easily number them as 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I've numbered them as like this. Now a quick question. Now we have converted it into a 1D. Okay, we've converted it into a 1D. Everyone's parent is he himself. Now let's assume initially the number of islands are 0. Okay, let's keep this. Now I have 0, 0. So let's take 0, 0. So this guy, is it previously an island? I see that no, it's not previously an island. So let's make it an island. The moment you make this an island, what will happen? If there is an island, it will get connected to some island that's above, that's on the right, that's on the bottom, that's on the left. Do you agree? It will get connected to all the islands that's on the top. This. Do you agree? If you are having an island here, it will get connected to here, to here, to here, to here. So as of now, what you see is, hey, listen, what I see as of now is, when I connect it to the right, it's not an island. When I connect it to the bottom, it's not an island. On the left, there is no one. On the right, there is no one. So apparently, this guy did not get connected to anyone. Hence, it's a new island in itself. So the number of islands will increase by 1. Hence, it's a new island in itself. Correct? And you can easily understand if, I'll go in the next direction and you'll understand. So let's assume the next one is 0, 1, where you have to put the island. Okay? 0, 1 is the next one where you have to put the island. 0, 1. Now the moment you have 0, 1, you see there is no island, so you put it over here. Now this 0, 1 says कि भाई right में कोई है? No, not an island. नीचे नहीं, ऊपर नहीं. But the moment it sees there is someone on the left, what you do is you say, hey, 2 or 2, you and me, let's get connected together. How can you do that? Union, isn't it? Can you do a union? If this guy has to be connected with this guy and said कि दोनों एक component को belong करते हैं, can you do a union? Yes, you can do a union. So the moment you do a union, it'll be probably something like this. 1 gets connected to 2 because 1 and 2. So 1 will get connected to 2. 1 will get connected to 2. So you have connected 1 to 2. Correct? So I have connected 1 to 2. Next, let's see what comes. Next, the element that comes in is 1, 2. So whenever I have a 1, 2, which apparently means over here. So this guy says, does it have anything on the left? No. So it did not find anything. So if it does not find anything, you will update the islands to 2. You will update the islands to 2 because it's a new one. So you update it to 2. Perfect. What's the next one? The next one comes out to be 2, 1. 2, 1. So when you have 2, 1, that means this again, nothing over here, nothing over here, nothing over here, nothing over here. So the number of islands will become 3. Okay, let's now have some brain, I probably keep it over here. 1,1. अभी मुझे यहां तुम बताओगे क्या होगा. If you place someone at 1,1 over here, what will happen? Tell me. This guy gets connected to this guy, isn't it? This guy gets connected to this guy. Yes, yes. फिर क्या होगा? This guy also gets connected to this guy. So it gets connected to two islands. It gets connected to two islands. Correct? So दो के जगह अब एक बच जाएंगे. दो के जगह अब एक बच जाएंगे. तो मैं क्या बोलूंगा? भाई दो माइनस कर ले क्योंकि दोनों को कनेक्ट किया एंड सिर्फ एक जोड़. तो अल्टीमेटली देयर इज नाउ जस्ट अ -1 that you will do. Why? Because there were two separate guys which got connected. So remove two guys that got connected. Why? Because क्या हुआ? 2,0 समझा नहीं मैंने ये वाला एग्जांपल नहीं. क्या हुआ? समझा नहीं. 2, क्या हुआ? ये वो 1,1 ले रहा हूं. क्या प्रॉब्लम है? क्या प्रॉब्लम है? जब ये बंदा ले रहा हूं 1,1, ये बंदा बोला मैं इसके साथ जुड़ जाऊंगा तो एक बंदे के साथ जुड़ा. अब ये बंदा बोला मैं इसके साथ भी जुड़ जाऊंगा तो और एक बंदा जुड़ा. तो टोटल दो आइलैंड के साथ जुड़ा ये. तो दोनों को एक बना दिया है. तो दो पहले हटा दे. अब एक तो बनाए खुद के वजह से वो एक तो बनाई है. तो +1. अंडरस्टूड हाउ टू डू दिस? हैव यू अंडरस्टूड हाउ टू डू दिस? क्या हुआ? 2 क्या बोल रहे हो? अच्छा 2,0. हाँ ठीक है भाई. ठीक है. सो हैव यू अंडरस्टैंड दिस? आ गया समझ? अब इसका मतलब है 5 को 2 से जोड़ने का, 5 को 6 से जोड़ने का. Has everyone understood how to do this? Wasn't it easy? If you know DSU, don't you think it was easy? आ गया ना? पक्का? Okay, perfect. Any doubts? Take some time. कोई भी डाउट है तो मेरे को बताओ. अगर लग रहा है कि कोई डाउट है तो बता सकते हो. If you think that there's any doubt, you can tell me. कोई डाउट लग रहा है तो फटाफट बताइएगा तो अपन देखेंगे. ठीक है, अपन देख लेंगे. So a question, how will you start with brute force? I don't think there is, like if you start with brute force, it's going to be very hectic because you're going to look at on the 4 directions. Brute force is probably like, if you think it is going to take a lot of time. Generally on these kind of questions, they expect you to come up with a direct solution most of the cases. कोड करें? इट्स इजी टू काउंट राइट. जो भी प्रीवियस आइलैंड का संख्या होगा उससे माइनस कर देने का. जितने लोग जुड़ गए अगर माइनस कर देने का, जितने लोग जुड़ गए हो गए. क्या कहना है कि नहीं? समझ में आया? एक बार वो 2 आइलैंड वाला पार्ट रिपीट कर दो. देखो सिद्धार्थ क्या हो रहा है. पहले आइलैंड्स कितने थे मेरे पास? एक ये था, एक ये था, एक ये था. 3 थे. 3 आइलैंड थे मेरे पास. अब मैं लेके आया एक बंदे को. अब ये बंदा बोला मैं इसके साथ जुड़ जाऊंगा. तो मैंने बोला ठीक है भाई, एक आइलैंड के साथ तू जुड़ गया. फिर मैंने बोला तू इसके साथ भी जुड़ा. अरे भाई तू फिर जुड़ गया. ठीक है, तो 2 आइलैंड के साथ वो जुड़ गया. तो 2 के साथ जुड़ने का मतलब क्या है? वो कॉमन बंदा है ना दोनों का. तो मतलब ये 2 आइलैंड को खा गया वो. एंड वो खुद से एक बनाया जो जिसमें वो खुद है, मतलब खुद से है ना. और अगर और किसी के साथ जुड़ता, लेकिन चारों डायरेक्शन में अगर जुड़ता वो, अगर वो चारों डायरेक्शन में जुड़ता सोचो, तो मतलब चारों आइलैंड को एक बना देता. चारों आइलैंड को एक बना देता तो -4 करता और +1 करता, क्योंकि चारों को एक बनाया ना. अगर 2 डायरेक्शन में जुड़ा तो मतलब अगर दो डायरेक्शन में जुड़ रहा है तो मतलब दो को एक बनाया तो -2 + 1. गॉट इट? अंडरस्टूड? Yes, you can use that too, but that will be brute force. If you do brute force, it's going to waste a lot of time. Generally, if you do a brute force, the brute force will be to figure out how many components are there. The brute force will be figure out how many components are there using DFS. But DFS is going to take a lot of time. That's big of n time that you will take to find it out, right? Oh, okay, but 4 elements. Okay, so shall I code? Clear है सब? कोड करें? कोड करें. क्या हम कोड करें? फक यू क्वेरीज. यस, ओके, कोड करते हैं. So as I said, industry level code. So let's take this. So what I'll do is, boom, interesting, and I put this over here. So the entire DSU is there. So what I'll do is, I'll create a DSU of DSU, and I will say n into m plus 1. Yes, I'll say n into m plus 1 because I am taking 1 based indexing. So I have the parent, I have the everything ready. Okay, I have everything ready. So मैं एक बार कंपाइल कर लेता हूँ. कोड का कंपाइलेशन सही है कि नहीं. मतलब कॉलिंग ए प्राइवेट कंस्ट्रक्टर प्राइवेट है क्या? Just checking out if there are errors. Yeah, cool. No error on my constructor. So yeah, we have this ready. So we have these positions. So you have to just iterate on the positions. So let's iterate on the positions. So I know int x is it of 0. I know the y coordinate is it of 1. And is there anything else on this? I don't think there is anything else. Okay, I don't think there is anything else. By the way, union and find नहीं, Amazon माइक्रोसॉफ्ट में भले ही नहीं पूछे. Amazon एंड माइक्रोसॉफ्ट में islands 1 पूछेंगे. Amazon एंड माइक्रोसॉफ्ट में islands 1 पूछेंगे. Island 1, you can do the island 1 question. That's easy. That's fair easy. Okay, so we have this. Okay, now I know something for sure. Int count is 1, and probably I can create a vector ka grid where like vector ka grid, and I can say this as grid of n comma vector of int m comma 0. Everything is 0. Okay, so what I can say is, अगर ये पहले से ही island है, if this is island from the first time, like if this is already an island, don't need to do anything because it's already an island. If someone else comes up and says, okay, let's make an island, then I'll make an island. So as of now, it's not an island, so I'll just make it an island now. Okay, let's make it an island. So I've made it an island. If it's not an island, I'll make it an island. And I know the 1D coordinate, or the index will be x into m plus y plus 1. I think that's how you get the 1D coordinate. 1D coordinate. So I got the 1D coordinate. So once I've got the 1D coordinate, I know there are 4 directions. So generally I do it like this: dx. You remember yesterday's class I told you this, dy. So this is something like -1 plus 1 0 comma 0. This is like 0 comma 0 and probably +1 and a -1. Yeah, and that is perfect. Now I know for sure the directions will be in 4. So direction lesser than 4, direction plus, and the count is 0 initially. Okay, so I know one thing for sure: for itself the count will always be 1. For itself the count will always be 1. And if there are 4 direction, the new x will be x plus dx of direction क्या हुआ? दिस इज अ फेयरली टफ क्वेश्चन, सो नहीं भी पूछ सकते हैं. एम एन इंटरचेंज क्यों करेंगे? एम एन इंटरचेंज उल्टा है क्या? उल्टा ग्रेड है. हाँ, थैंक यू थैंक यू थैंक यू थैंक यू थैंक यू थैंक यू. उल्टा ग्रेड है. इट्स एन ऑपोजिट ग्रेड, सो नॉट एन इशू. ओके, सो new y plus dy direction, and what I'll do is, listen, what I'll do is, I have a new x, I have a new y. So what I know is I need to find the 1D coordinate. So probably I can say that the 1D coordinate will become, index ले लेते हैं, index 2 ले लेते हैं, इसको index 1 ले लेते हैं. So index 2 will become new x into m plus y plus 1. Looks perfect now. New y, sorry, new y plus 1. Now what I need to do is, if they belong to same, so I'll say find parent, or DSU is created, so I'll say DSU dot find parent. ये देखो मतलब कितना slow है ये. Find parent index 1. If the find parent, like both of them belong to different components, DSU dot find parent index, if both of them belong to different components, then I will say, okay, hey, listen, they belong to different components. That means you're attaching them. So one element will be less for sure because you're attaching them. And one thing I know for sure is, what if, okay, there's an edge case. Can you think of an edge case? Can you think of an edge case? Can you think of an edge case? सोच सकते हो कि एक एज केस का कोई सोच सकता है? एक एज केस का कुछ ऐसा, ये वाला एज केस का कैसे सॉल्व करोगे? मतलब ये किसी मैंने भी नहीं सोचा. हाउ विल यू सॉल्व समथिंग लाइक दिस? व्हाट इफ यू हैव 1 1 1 1 1? सो द मोमेंट यू ऐड अ 1 हियर, दैट डजंट मैटर बिकॉज यू विल बी लाइक इससे भी कम करो, बट ये ऑलरेडी एक ही है, ये ऑलरेडी एक ही है, तो बट यू विल एंड अप सब्ट्रैक्टिंग 2. You will end up subtracting 2. How will you solve this? You'll end up subtracting, just because this got connected and just because this got connected, you'll end up subtracting 2. So how will you handle that? Any idea? Any idea how will you handle that? Like I probably cannot think of something, but can you think of something? सोचते हैं कैसे अपन कैसे इसको एंड कर सकते हैं. How can I do this? अगर मैं इसको यहाँ से भी है और उनका यहाँ भी है, ठीक है. अच्छा, पेरेंट तो बराबर ही आ जाएंगे दोनों के. नहीं सही है. इट्स करेक्ट. या parent will be same. Yeah, parent will be same. In this such case, the parent will ultimately be same, because once you connect these two guys, the parent will automatically be same. Yeah, everyone's correct. Union by size. Now I'll do union. You do by size, by rank, whatever you do, just make sure you do it always. Like if you do union size, just make sure you always do it union by size, and then you can say index 1, index 2 can get connected. I think that should be, I think that should be it. If you connect them, if you do this, and at the end of the day, probably if you keep a vector of answer over here which you can store all the answers, then if you're doing a continue, so you need to store the answer. So probably answer will be dot pushback of count, and this will also be answer of pushback count after the follow. Yeah, I think this should work. Return करना भूल गया. This should work, I guess. अरे यार, अब क्या पंगा है ये हर दिन आ जाता है ये पंगा बचाने. इसको क्या प्रॉब्लम है भाई? ये क्या प्रॉब्लम है भाई? लाइन नंबर किस में है इसको प्रॉब्लम है? लाइन 103. अरे भाई कौन सा लाइन है भाई? वेक्टर में प्रॉब्लम है. वेक्टर और वेक्टर इंट सही तो है. Vector of vector int n cross vector int. It's okay, right? Oh, out of boundary, right? Yeah, out of boundary. Yeah, I forgot to check the boundary conditions. Absolutely sorry. I forgot to check the boundary conditions. Yeah, new x should be greater than equal to 0, and new y should be greater than equal to 0, and new x should be lesser than m, and new y should be lesser than m, and grid of should be new x, new y should be island. Okay, I think now it works fine. अभी भी रन टाइम एरर. और क्या है? Also check if yeah. I have checked that. What's the other thing? New x new y अगर मैंने चेक कर लिया है. और क्या चेक करना है? एक सेकंड रुको कि इस लाइन की वजह से आ रहा है या किसी और लाइन की वजह से आ रहा है. देखते हैं. इसी लाइन की वजह से आ रहा है. इस लाइन में कुछ पंगे हैं. लेट्स सी क्या पंगे हैं. क्या इस लाइन की वजह से पंगे हैं? No, this line is okay. Should be greater, should be less. Once it's less, it's okay to check. ऐसा ही तो है यार. अब क्या पंगे आ रहे हैं इसको? और पंगे तो इसी की वजह से हो रहे हैं. कोऑर्डिनेट्स उल्टे हैं. कहाँ कोऑर्डिनेट्स उल्टे हैं? कोऑर्डिनेट्स भी उल्टा दिया है क्या? नहीं कोऑर्डिनेट्स तो सही दिया आपको. नहीं कोऑर्डिनेट्स आर ओके. Okay, let's quickly do a debug. New x, new y. Are we having this correctly, by the way? Dx dy minus 1 plus 1 0 plus 1 say तो maybe. नहीं वो सही है. This is okay. New x is okay. Lesser than m and lesser than m is okay because I've swapped it over here. So it should be okay. Not a big deal. It should be okay. कुछ और इशू है यार पंगा हर दिन का ही हो रहा है आजकल तो. No, why should it be lesser than equal to n? No, it's lesser than n. No, it's okay. I've swapped it over here. Guys. For everyone who's watching it now, we have swapped it over here. But not in coordinate vector. कोऑर्डिनेट वेक्टर में क्यों करना है भाई? ये सही है यार. कोऑर्डिनेट वेक्टर में क्यों करना है अपने को? पोजीशंस तो सही आ रहे होंगे. उसमें क्या इश्यूज है? एनएम भी तो किया हूँ मैंने वेक्टर. ओके फटाफट देखता हूँ क्यों पंगे आ सकते हैं. ये यहाँ प्रिंट कर देते हैं ना, पता चल जाएगा. No. I don't think that's a problem. अरे और थोड़ी होगा भाई. वो सही है. रुको एक को हटा के देखते हैं कहाँ पंगे आ रहे हैं. एक को हटा के देखूंगा. ठीक है इसकी वजह से नहीं है. ये पूरा हटा देता हूँ इसकी वजह से. ओके Why is the mistake coming? रुको एक सेकंड रुको. इसको मैं डिबग करके ही रहूँगा आज तो. ग्रेटर देन 0 है, लेसर देन m. ऑफसेट ओवरफ्लो हो गया. ओवरफ्लो कितनी इसकी वैल्यू कितनी? 10⁴ है. n की पोजीशन लाइन 10⁴ है. ओवरफ्लो है इसके हिसाब से। एडिशन ऑफ अनसाइंड ऑफसेट टू ओवरफ्लोड stl vector डॉट एच। वेक्टर में एडिशन हो रहा है ओवरफ्लो का। चलिए why there is new y plus 1 कहाँ है? सही है यार। हु 11 भी आया। 11 क्यों आएगा? 339 10 आना चाहिए एट मैक्स। 11 भी सही है। सिर्फ इसको प्रिंट करता हूँ एक सेकंड। इंडेक्स 1 कितना है? 168। ये भी सही है। अगर मैं कोड करूँ और मैं डिकोड कर दूँ उसको, डिकोड भी कर दूँ इसको। Line 91. Someone says line 91 is a problem. I don't think line 91 is a problem. एक कुछ छोटा सा मिस्टेक हुआ होगा जो हमें नजर नहीं आ रहा है। दिखते हैं। नहीं, अब ब्रेक पॉइंट की वजह से नहीं हो रहा है। इट्स नॉट ड्यू टू ब्रेक पॉइंट। लाइक रुको, मैं डिबगर यूज़ तो नहीं करता बट ठीक है कर लेते हैं। कैसे यूज़ करते हैं वो पता नहीं है वैसे। हाउ टू यूज़ डिबगर का? डिबगर क्या है भाई? तो डिबगर रुक, हाँ ये है शायद। नहीं 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 नहीं, डेटा सेटिंग, फॉन्ट साइज, बस डिबगर। एनीवेज ओके 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 ओके, कहाँ गलती हो सकता है? अब मेरा दिमाग गर्म हो रहा है। चल जा भाई। At 69, but why is that the problem? नहीं, line number 31, I don't think that's the problem. I think something else is the problem, which I'm not able to figure out as of now. Okay. Works for first element. Works for first element. Let's add one more. जीरो वन जब ऐड हुआ, ऐसा क्या खास कर दिया भाई बंदे ने? 01 को पहले लेते हैं। ऐसा क्या तू खास कर रहा है भाई जो फट जा रहा है? हाँ, 0,0 ऐसा क्या खास कर रहा है जो फट जा रहा है? ना ना ना। फिर रन इट, इट्स फाइन। रन कोड डिबगर वही है, कहाँ है? ओके मिलना तो है ही। ये 0,0 पे जाके फट रहा है, देख रहे हो? न्यू एक्स को बोल रहा है जब तू 0,0 है तब तू फट जाए। क्यों? 0 इंटू एम क्या होगा? ये तो यार 4 पहले पकड़ा, चारों डायरेक्शन, 0,0 पे जाके उसने फट गया। क्यों फट रहा है भाई तू? ऐसे तुझे क्या प्रॉब्लम हो गई तो फट जा रहा है? यूनियन साइज जब मैं बोलता हूँ तो मैं बोलता हूँ इंडेक्स 1 जा और इंडेक्स 2 जा। रन कोड कहाँ है? डिबगर रन कोड रिजल्ट के नेक्स्ट है डिबगर। कहाँ है? कहाँ दिख रहा है भाई? ये तो नहीं है, ये भी नहीं है। ये क्या है भाई? कहाँ है? ये कहाँ दिखता है भाई तुम लोग को डिबगर? टेस्ट केस के थर्ड पे है डिबगर। टेस्ट केस के थर्ड पे। टेस्ट केस के थर्ड। ओहो नाइस। क्लिक द लाइन टू ऐड ब्रेक पॉइंट्स। ओके लेट्स ऐड अ ब्रेक पॉइंट हियर। ऐसे ऐड करते हैं। नाइस डिबग। we have nice. Okay, भाई इससे अच्छा तो मैं खुद ही कर लूँगा, ये क्या दे रहा है ये? यहाँ फटा है, 0 0 पे फटा, क्यों फटा देखते हैं। ग्रिड ऑफ बोला 0 0 1 है, 0 ग्रेटर लेस है 1 है। DSU डॉट फाइंड पेरेंट का जब वो 0 निकालने 0 इंटू एम प्लस 1, फाइंड पेरेंट का 1 निकाल, जब 1 पे गया तो फट गया। No, I don't think that's the case. I don't think that's the case. I don't think that's the case because over here they're given m into n and RICI is given to according to this. ठीक है, तो ये वाला सही है, ये पंगा नहीं है. This is not a पंगा because over here वैसे भी 3x3 है. There's something else that I'm not able to probably debug. I'll come back. तो मैं एक बार लास्ट ट्राई मारता हूँ, हुआ तो हुआ, नहीं तो फिर बाद में देख लेंगे. बाकी लॉजिक तो क्लियर ही है. हो क्यों नहीं होगा ये, मतलब किस वजह से फट सकता है? मेरा DSU की वजह से ही फटेगा अगर फट रहा है तो. अगर मेरा फट रहा है तो ये बंदा सिर्फ DSU की वजह से फट रहा है. रन टाइम एरर आ रहा है. रन टाइम एरर का मतलब बोले तो ये पक्का से कुछ ऐसा पे जा रहा होगा जिसको उसको मिल ही नहीं रहा होगा पेरेंट. भाई साहब पेरेंट मिल ही नहीं रहा होगा ना. हाँ ना, अगर मैं पेरेंट चिपका ही नहीं रहा हूँ तो पेरेंट मिलेगा कैसे? तो मेरा पेरेंट वो ही बंदा है. मैं दोनों का पेरेंट निकाल रहा हूँ. ओहो, मैं क्या बोल रहा हूँ? DSU फाइंड पेरेंट, इंडेक्स 1 का पेरेंट निकाल और इंडेक्स 2 का निकाल. यूनियन को भी बोल रहा हूँ, तू भी निकाल. और ये लोग क्या बोल रहे हैं कि फाइंड पेरेंट ऑफ यू निकालो, फाइंड पेरेंट ऑफ वी निकालो. I think the main problem that has came over here, what I personally feel is the parent वाला ही runtime error दे रहा है. Like if I just remove this line, and if I run, then it will work. No, it will not work. And if I remove this, probably it will work. Let's see. Yeah, I think main problem is under DSU का union size and under this index 1 and index 2 में ही main problem है. So probably if we just print out index 1 and index 2, I think we will get to know where's the problem. Let's do it over here and we'll get the problem. 2,1 यूनियन में इशू है या यूनियन में ही इशू है या यूनियन में इशू है. आई ऑल्सो फाइंड आउट यूनियन में इशू है. सो एक बार सी आउट ऑफ फाइंड पेरेंट ऑफ इंडेक्स 1 मारते हैं तो ये फट जाएगा. इधर ही फट जाना चाहिए. जब फर्स्ट टाइम ही आएगा तो फट जाएगा. I think there is a problem over here. Yeah, इधर ही पंगा है. I think the problem is here on a find parent. Is the find parent getting set? Like when I'm doing a DSU, n into m plus 1. Let's see if it is going there and setting it. It's very important to understand this. If I'm doing it here. ओहो आया समझ में क्या पंगा है भाई साहब. Parent dot push back 0, parent dot push back because we should have started from 0 because the 0th index will not contain na. The 0th index will not contain, right? ना मुसीबत. अब चल जाएगा. Did you understand क्या क्या इशू हुआ था? अब चल जाएगा. अब एटलीस्ट ये तो आ गया. चलो कोई नहीं. अब हम लोग अब तो हो जाएगा हम लोगों से, तो इश्यू तो नहीं होना चाहिए. ओके 0 -1 वे करेंगे -1. अभी भी कुछ छोड़ गया लग रहा है, कोई नहीं कर लेते हैं. अब हो जाएगा, अब इश्यू नहीं है. ओके कूल. सो काउंटर प्लस प्लस कहाँ है? काउंटर प्लस प्लस कहाँ गया रे? Finally. Yeah, this was the main problem. Oh yeah. We started from 1, so when we did a pushback on the 0th index we had 1, on the 1th index we had 1. That is the problem. So just make sure you debug like this whenever you face problem. I always debug like this. edge case नहीं आएगा क्योंकि वो सेम ही है. या कोड समराइज कर देता हूँ. सो ये ऑलवेज ट्राई टू लाइक ये वाला DSU को स्टोर कर लेना. लाइक कीप दिस DSU and whenever you have to always use it in a competitive programming. The issue was this, like I was starting from 1. Okay, so basically when I did a parent dot pushback, तो 0th पोजीशन पे 1 था, 1th पोजीशन पे 2 था, 2th पोजीशन पे 3 था. तो there was the parent was not same. As I said, एक बंदे का सेम parent होगा तो इधर 1 से शुरू था, इधर 0 से शुरू होना चाहिए था. Should have start from 0. Yeah. Understood what was the problem? Did you understand what was the problem? Like, did you understand what was the problem? Where did we face a problem? Did everyone understand where did we lag? Did everyone understand where did we lag? Whether did you learn debugging? How do generally people debug? Like if you put a 1 over here, तो parent array कैसे बनेगा? Start from at 0th index it will have 1. At first index it will have 2, right? We don't want that. We want वो खुद का parent खुद दो. That's why. So did everyone understand debugging? Like generally you have to debug like this. ठीक है? Okay. Cool. So remember one thing. If always keep this class ready with you. See, if I had this class ready, I did not do anything. I just wrote a simple code where I just created an object. And I simply used that. See, I created an object of DSU and I simply used the functions. Did I do anything special? ठीक है, मैं कोड दे दूंगा लास्ट में. Don't worry, I'll give you the code. Okay, so let's quickly summarize the what I did. I basically initially swapped m and n. Why did I swap? Because it's basically given as m was given as greater than n, right? M was given as greater than n, so that's why I swapped it. Then I did n into m plus 1 because I'm doing in 1D. After that grid that I have defined, then a dx dy, and then I had positions where I had x and y. And after that what I did was चारों डायरेक्शन में गया एंड चारों डायरेक्शन में जाके देखा क्या भाई तू पहले से आइलैंड है, अगर है तो क्या तू पहले से कनेक्टेड है मेरे से, अगर है नहीं है तो भाई हो जा और एक आइलैंड कम कर दे, बस लास्ट में जो आइलैंड है. ठीक है. yes always remember every code should be in class, right? Class based codes, so that whenever you want to use it you just create an object and you can have a constructor. See, this is having a constructor. You don't have to also always change the value of integers. array का size भी change नहीं करना है, ये automatic हो जाएगा. तुम्हें जितने भी size का चाहिए तुम यहाँ पे DSU का object बनाओ एंड उतने साइज का बुला लो, वो ऑटोमेटिक उतने साइज का सब कुछ बन के रेडी हो जाएगा, है कि नहीं? डिड यू फाइंड दिस वे बेटर टू कोड, लाइक हैविंग एन ऑब्जेक्ट एंड क्रिएटिंग दिस? और एक डीएसयू चाहिए मुझे, और एक डीएसयू चाहिए, आई वांट वन मोर, आई डोंट हैव टू राइट टू फंक्शंस, I get DSU 2 of 10 size. If I want one more DSU, if I want 3 DSUs, a single piece of code is being used repeatedly. That's why I call it as production based code. Okay? Yes. Always do that 1D conversion. The reason I say you should do 1D conversion is because that helps you to basically do this 1D arrays. ये 1D arrays है ना, तो it helps you. Otherwise, you have to take a 2D and it gets very much confusing. Okay, so UQ from everyone if everyone is clear of this question. Okay, so I'll do one question which is from Code Forces, which is roads not only in Berlin. That will be the last question for the day. It's a D-level question. It's a D-level question and known as the roads not only in Berlin. The question is rated 1900 and that's what we'll do it. ठीक है, question पढ़ लो. अबे क्या copy paste same code. If you go to WhatsApp, does WhatsApp does this कि एक ही डिजाइन 10 बार कॉपी करके 10 तो चैट स्क्रीन बनाएगा? तुम 200 जन से बात करते हो और 200 तो चैट स्क्रीन बनाता होगा, तुम्हें लगता है 200 तो चैट स्क्रीन बनाता होगा? नहीं, इट्स वन चैट स्क्रीन दैट्स जस्ट पेस्टेड एवरीवेयर. फ्रेमवर्क्स मैन. व्हाट्स द टाइम नाउ? Goodness gracious, 12:30. Last question. Okay, last question for the day. आ जाएगा यार, मैं समझा रहा हूँ ना, डोंट वरी, मैं समझाऊंगा तो पानी की तरह आएगा. लास्ट क्वेश्चन करते हैं. हाउ मेनी ऑफ यू आर इंटरेस्टेड इन डूइंग दिस प्रॉब्लम? 1900. हाउ मेनी ऑफ यू like the stream if you're watching till now? How many of you are interested in doing this problem? I know it's 12:30, but yeah, if you're interested, I'll do that. Otherwise, I'll leave this. How many of you can you give a thumbs up if you're interested in doing this? I'll make this easy, don't worry. I'll make this easy, but how many of you are interested? Interested, okay, perfect. ठीक है, इंटरेस्टेड. ओके, रीड द क्वेश्चन. कल फिर क्या होगा? कल नया ऑडियंस आएंगे, वो बोलेंगे भाई हमें तो डीएसयू आता नहीं है, कल का क्लास नहीं किए, फिर पोपट. अभी कर लो या फिर छोड़ देता हूँ. कल तो नहीं हो पाएगा, फिर क्या होगा? नए बंदे आएंगे, वो बोलेंगे भाई साहब मुझे तो आता नहीं है डीएसयू. ओके, मैं फटाफट क्वेश्चन लिख लेता हूँ, मैं समझा दूंगा क्वेश्चन. फटाफट करते हैं, ठीक है? Okay, so let's understand the question. Okay, let's understand the question. So the question states there is a city of Berlin. Okay, the question states there is a city of Berlin. Okay, so there is an entire city of Berlin. So in Berlin there are cities. These are cities. These cities are connected by connected by edges. These cities are connected by edges. Now again, these are the cities that are connected by edges. Now the Minister or Home Affairs of Berlin states ki I want to connect all the cities. As of now, this portion of the country is separated from this portion of the country. Whereas like these cities are connected, but probably समझ लो यहाँ पानी है, कहीं पानी है. So these are not connected. Okay. So what they are saying is, I want you to connect this portion of the city to this portion of the city. Okay, but Berlin is very poor. The city is very poor. So what he says is, जो पुराने रोड है तुम उसी को यूज करो. Assume this is a constant bridge. This is a 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 bridge. So Berlin says, I don't have money. You cannot create new roads. What you can do is probably you can take up some different things. So I will say, okay, I'll pick up this guy. So what I'll say is, चलो इस रोड को उठाते हैं. The road between 1 and 3 I'll pick up, and probably I'll connect 3 and 7. So what I did was, I took a road that was here and I pasted it here. Now can I say the entire city is connected? Now can I say that the entire city is connected and you can reach from any city to any other city? Can I say that? Now you can reach from any city to any other city. Can you say that? Yes or no? How many of you agree that this is perfect? Do you agree that this is perfect? right? So the question states that it could have been done in other way also. It could have been done in other way also. What if I say, hey, listen, let's not remove this. Yes, let's not remove this city. Instead of that, let's remove this city. Okay, and probably you can say let's connect 2 and 4. Doesn't matter. Like you can connect any one. Let's remove this and connect this. You can remove any road. You can remove any road, and what you can do is you can just connect to the new city. Now can I say that ultimately, like for this, the answer will be removal of 1 2 and addition of 2 4. So they basically want you to say which roads will you remove and which roads will you connect. So there can be multiple answers. Like for this particular set of graph, there are multiple answers, but we just need any one set of answers. So probably you can print this, or you can print this, or there can be multiple where you say this can be removed or this can be removed. As long as you are connecting everyone, it's absolutely perfect. Has everyone understood the question? UQ guys, has everyone understood the question? Perfect. Okay. So first, how will you solve the question? Generally, if this question comes up in code forces, I generally approach the question like this. Acha, question ko todu kaise? The first thing that comes to my mind is how many new roads are required? How many new roads do I need to build? Okay, how many new roads do I need to build? So I say that, okay, over here I'm connecting different portions of the cities which are not connected, which essentially means if there is one component, other component, like essentially, which means if there are 4 components, logically how many roads do I require? Can you tell me how many new roads will I require if there are 4 components? What do you think? What do you think? How many new roads will I require if I have 4 different portions of the cities which are not connected? 3, right? Okay, so something that comes to my brain is if at the end of the day, the number of components is x, the number of new roads will always be x minus 1. So that is something which I figured out. So generally in code forces I would have done this at first. So I would have done this. Okay, now in order to create these x minus 1 roads, I need old roads. Now I will be like, which roads can I take? So I'll be like, take those roads which does not break the connection. Now I'll be like, how will I figure this out? That's very simple. So can I say this? Take those roads which do not break the connection. So I have also figured out old roads कहाँ से लेंगे, new roads कितने लगेंगे. हो गया 2 portion of question solved. Right? Now my brain says, okay, but how will I take those roads which do not break the connection? Loop. Probably not. Something better because loop वाला फिर बहुत complicated हो जाएगा. Something better. Loop wala will get complicated. No, cycles will get complicated because there might be a lot of cycles. Which will I break? If I think of code, it will become complicated. Can I say, if someone is like in this question, they said an edge between 1 and 2, an edge between 2 and 3, an edge between 1 and 3. So can I say, what I will do is, let's connect the first edge. So 1 and 2 gets connected. Let's connect the second edge. 2 and 3 gets connected. So the moment you try to connect 1 and 3, what do you figure out? While you're trying to connect, you say that, hey, 1 belongs to the same component, 3 belongs to the same component. 1 belongs to the same component, 3 belongs to the same component. So if they belong to the same component, can I say this road is a part of the old road? So can I say, whatever edges are given to me, I will try to connect them. And if I find that the parent is equal to the parent, like of both the nodes, can I say that those are old roads? So while connecting edges, if any of the edges, like or any of the nodes belong, like have same parent, can I say those are old roads? So instead of cycle, did I make it easy just by finding out, like if u and v is given, I just need to figure out the parent of u, parent of v, ultimate parent, and once I figured out the ultimate parent, can I say if they have the same ultimate parent, then they will belong to old road? Yes. So I have old roads now. I have old roads. So I have solved this question. So this question specifically is very sure कि जितना requirement होगा उतना तो minimum old roads होगा ही. This is something very sure that this is greater than this. The number of old roads will always be greater than equal to number of new roads. Like if you solve this question, you'll see that. So there is no need to put an extra check. But you can also put a check. Now, number of new roads is component minus one. ठीक है, नंबर ऑफ न्यू रोड्स इज कंपोनेंट माइनस वन. भैया फिर से समझा दो, क्या समझाना है इसमें? इजी तो था. अगर वन और टू को जोड़ने बोला, वन और दो अलग थे तो जोड़ दिया. टू और थ्री को बोला, टू और थ्री अलग थे, जोड़ दिया. वन और थ्री को जोड़ने बोला तो दो तो ऑलरेडी जुड़े हुए थे, तो वो रोड तो एक एक्स्ट्रा रोड है ना. दैट रोड इज एन एक्स्ट्रा रोड, इजंट इट? इट्स एन एक्स्ट्रा रोड. सो यू जस्ट स्टोर दैट एक्स्ट्रा रोड. सो हाउ डू यू फिगर आउट एक्स्ट्रा रोड? द एक्स्ट्रा रोड कैन बी easily figured out if you see that those belong to the same component. Okay, got it, Priyam? Okay, now question is, how do you figure out which are the new roads? How do you figure out which are the new roads? First, this is a component, this is a component, this is a component, this is a component, this is a component. Does every component have a unique parent? Does every component will have a unique ultimate parent? Don't you think? This will also have a unique ultimate parent. This will also have a unique ultimate parent. So can I take this unique guy and connect to this? Then can I take this unique guy and connect to this? Can I take this unique guy and connect to this? Can I take this unique guy and connect to this? Do you agree? Do you agree? In that way, can I connect all the components? These are my old new roads. The first new road is this. The second new road is this. The third new road is this. The fourth new road is this. Agree? Now, how do you find the connected components? If you store everyone's ultimate parent in a set, if you store all the edges, all the nodes, all the n nodes, you ultimate parents in a set, don't you think the set size will be the number of components? Do you agree? Do you agree? If you store all the parents in a set, and the set size will be the number of components. Yes? So if I summarize the question, doesn't the question mean store extra roads if parents different while connecting, right? Next, find number of components. Find number of components by using set and parents. Next, use adjacent unique parents to build new roads. How many of you agree that these are the 3 steps? And how many of you have understood all the 3 steps? UQ, please. How many of you have understood all the 3 steps? UQ, please. How many of you understood all the 3 steps? This is the most late night stream I'm doing. It's 1 o'clock. It's 1 o'clock in the night, and I'm streaming almost 1 o'clock. Please make sure you like this. Like कर देना, दिल से like कर देना है भाई. ठीक है, कोड करें, चलो कोड करते हैं. I'll implement all the steps. Don't worry, I'll implement all the steps. Okay, so void roads in Berlin. Voids road in Berlin. Okay, so what I'll say is initially I'll create a DSU. So first let's take n and the number of edges that is given to you. The number of nodes and the number of edges is given to you. I'll create a DSU of size as number of nodes, which is n plus 1, and then probably I'll take all the edges as saying from 0 to m, and I'll do an int plus plus, and then I'll take an int u v, and I'll try to connect them. So something that I'll do always is if DSU dot find parent of u is equal to DSU dot find parent of v, then that's an old road. That's a repetitive road. So probably I can use a pair old road, you can call it, or extra road, you can call it extra road. So I can say extra road dot push back of pair of u comma v, or else you'll be like, hey, can you do a DSU dot union of u comma v? Understood? मैंने भी अभी तक खाना नहीं खाया. I haven't also done a dinner till now. मैंने अभी भी डिनर नहीं किया. सो या आई कुड हैव सेड कि तुम लोग कर लो, बट ठीक है कर देता हूँ, इससे ज़्यादा मेरे को टाइम नहीं लगेगा. सो आई हैव डन दिस राइट, DSU डॉट यूनियन. नेक्स्ट स्टेप 1 इज डन. Step 1 storage of old roads is done. Next, figure out the number of compos, that's components. So how's that done? Set of int, and then you can take a set, and then probably you can just loop across and do this. And how will you do this? How will you find the ultimate parent? So for set dot insert, find like DSU find parent of I. So make sure you use DSU dot find parent. Just don't do DS like parent मत use करना, ठीक है. Parent मत use करना, ठीक है. Parent मत use करना. मतलब if you use parent array, then it will be wrong. You have to call find parent. Ultimate, always ultimate, ठीक है. Okay. So can I say x is st dot size? I can say x is st dot size. And can I say that the number of rows required will definitely be x minus 1. So I also know this. I probably will declare a vector, and I'll say vector vec st dot begin. So this will put every other thing into this, like all the unique parents into this. Now I can iterate from 0 till vector, like I need x minus 1 row, so x minus 1 and I plus, like I can iterate like this. And what I can definitely say is see out, like old road I can do is old, like something like probably you can keep it like this, int j equal to 0, and you can say extra road of I dot first this extra road of I dot second, right, and this and vec of I and vec of I minus 1. And then you can do a j plus plus. So basically, sorry, j. Basically if you do this, I think that will work. छोटा सा कोड है, देखो. अरे भाई अब मतलब रात को इतना बजे क्या, मतलब ये सब पॉइंट करोगे क्या? इंसर्ट क्या कर रहे हो? Understood everyone? Has everyone understood this? Like if I just do it, and if I just quickly run it, like roads not only in Berlin, Okay, let's take this. इसको मैं सबमिट नहीं करूँगा, सबमिट खुद कर लेना. मुझे कोड फोर्सेस लॉगिन करना पड़ेगा, विच पता नहीं कहाँ होगा मेरा आईडी. मुझे जीमेल फीमेल यूज़ करता हूँ तो आई कैन नॉट. आई होप यू अंडरस्टैंड. Okay, so yeah. DSU.union, union by size होगा वैसे. कर लेना अब मतलब समझ गया ना, अंडरस्टूड ना. Third part, explain. Okay, this part is basically I am iterating from I equal to the number of components, and I'm saying this is the extra route that I'll take. Okay, that's the first dot. Second, because I've stored in pairs, and the components like the unique parents are stored here. So I'll just take it from this one, like so and so on. क्या हो गया, कुछ ये कुछ और इशू आया मतलब. I don't think this is an issue with like कुछ और इशू है. Bash line one segmentation. It's some different issue. I'll fix. अच्छा ये input output का कुछ issue हुआ होगा. Anyways, like if I solve it somewhere else, it will work. If I solve it somewhere else, it will probably work. Not sure. अब ये कोड के वैसे नहीं हो रहा है, कुछ और इशू के वैसे हो रहा है. या चल गया, हट ऑफ चल गया. ये कुछ और प्रिंट हो गया मतलब 0 0 मतलब इग्नोर मारा है इसको. एक सेकेंड. वाह वाह, मैं बहुत महान हूँ. I've copied the wrong one, man. Shit. It will always have. Okay, so it will always have m-1 edges. My bad. My bad. Yes. Yeah, done. I can use my username. I don't remember the password. I don't use it daily now. That's why I don't. Cool. वैक भी जे कर देना. वैक भी जे कर देना. वैक कहाँ जे करना है? नहीं, वैक जे नहीं होगा ना, क्योंकि मैंने वेक्टर में कंपोनेंट्स रखा है, तो एडजेसेंट 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 लेना होगा, है कि नहीं, राइट. एंड उधर पेयर रखा था तो इसीलिए एक्स्ट्रा रोड. ये इम्प्लीमेंटेशन तो खुद कर लोगे यार. Done with the stream today. We had a wonderful stream. Did you enjoy this? Did you enjoy today? Did you learn DSU? 1900. सच बताना, 1900 लगा? 1900 लगा? सच बताना. Did it feel like 1900? Did it feel like 1900? Please make sure you like the stream. Share code. Yeah, I'll share this now. Let me share the entire code of this as well as the other one. This is number of islands का भी कर देता हूँ, काम फाम आ जाएगा. ये पूरा अभी तक का ग्राफ का क्लास में हर दिन का ही शेयर करता रहता हूँ. चिपका दिया, खोज लेना. देखो आईडी में मारता हूँ. Always make sure you code using DSU class and object. आज सबसे अच्छा कौन सा चीज, आज कौन सा मस्त है मजा, आज सबसे ज्यादा कौन सा चीज सीखा? क्लास वाला कॉन्सेप्ट समझा. हर बार सेगमेंटरी करो, कुछ भी करो, ऑलवेज मेक क्लास एंड क्रिएट इट. ओके भाई, कोई सौरभ को पकड़ के पीटो. टेल हिम इट्स 1 o'clock in the night. Tell him it's 1 o'clock in the night. Tell him it's 1 o'clock in the night. He's telling me to solve one more problem. मेरे को घर से निकाल देंगे. मैं धीरे बोल रहा हूँ. चलो मैं रखता हूँ. Bye guys. Good night. Take care. I thoroughly enjoyed it. Tomorrow we'll be learning about Kruskal's algorithm. That's minimum spanning tree. And then I'll be telling you, like, minimum spanning tree is based on this. Then I'll be telling you Bellman-Ford algo. And once you're done with Bellman-Ford, probably I'll be solving the problem alien dictionary that was left. Yeah, and bridges and articulation points karenge, and then we will wrap up the graph masterclass. Okay, good night. Bye-bye.